Yes, screen is visible.
Yes, sir.
Yes, sir.
Yes.
Yes. Last class, Thevenin theorems. What we did, remove the load resistance RL. Then we found the open circuit voltage, that is VTH. Then we find the resistance from seeing from the points where we removed that load resistance. Then we are going to calculate the RTH. Okay, then replace whole network by VTH and RTH, calculated VTH and RTH. Okay, that is the equivalent Thevenin circuit. Here for Norton's, see, Norton's theorem. Okay, what it states? It states that any two terminal of a network, any two terminal of a network can be replaced by an equivalent circuit where, see, any two terminal of the network. I am going to see, consider this one as one network. It's having two terminals. Okay, then the load resistance RL. Terminal, I'm going to call this terminal A and B. This is my network. Okay, now what it states? It states that any two terminals of a network, this network, can be replaced by an equivalent current source and an equivalent parallel resistance. It means I am going to replace this network having two terminals A and B. I am going to replace this with an equivalent current source in parallel with the internal resistance. Okay, so I can draw like this. This is my current source and one resistance in parallel with that current source. These are two terminals A, B and resistance RL. Okay, here what I did, I replaced this network with this. This is, we can call it as IN. This one as RN. Okay, now here IL and IL. Now the constant current, this constant current, this constant current is equal to the current which would flow in a short circuit placed across the terminals. In the sense, whenever they are going to ask some questions like find the current through 10 ohm resistors, one circuit is given, they are going to ask 10 ohm resistance, where for finding IN we need to short that 10 ohm resistance. Okay, now we'll see one problem, then we'll get to know. Here the current through 10 ohm resistors in the given network. The network is like this. Where in the Thevenin theorem we found out the open circuit voltage. Here short circuit current. Okay, one more resistance. this 10 ohm resistance, 10 ohm, 5 ohm, 4 ampere, 15 ohm, 1 ohm and 2 volts. Okay, in question, find the current through 10 ohm resistor. Here in Norton theorem, we need to short that 10 ohm. Okay, in Thevenin, we are going to open that 10 ohm. Okay, now let's see. If I'm going to find the current with 10 ohm, I'm going to consider this one as IN. Okay, here I'm going to short this one. Fine. I short this one. Then I'm going to mark here IN. Okay. Then I'm going to consider this 10 ohm points. This one as A, this one as B. Okay, before short circuiting this A and B points, 10 ohm resistor is there. Okay, in question they asked find the current through 10 ohm resistor, so I short circuited 10 ohm resistance. Okay, I marked that 10 ohm resistor terminal A and B. Okay, now I need to mark loop currents. Fine. How many loops are there? Yes. How many loops are there? Three loops are there. Three loop currents. I1, I2 and I3. Three loops, three loop current, IN. Okay. Now apply KVL to mesh 1 or loop 1. This is my mesh 1, mesh 2, mesh 3. Now I'm going to apply KVL for mesh 1. Yeah, tell me. Minus to plus. Here I'll mark plus minus plus minus plus minus. This is minus. This is plus. Tell me for loop 1, this mesh 1. Minus to positive, plus 2. Next.
Minus I1.
Minus 1 I1 or I1. Here there is no element in this path, AB path. There is no resistance, inductance. Okay, so 0, that is 2 I1 equals to 0. So I1 equals to plus 2. Correct? Applying KVL for loop 1, I got I1 equal to plus 2. Okay, here we can see loop 2 and loop 3 form a super mesh. Why? Because the current source is common for both the loops. Okay, now we need to write the equation for super mesh. Okay, I3 is in same direction of this 4 ampere current source. So see, first next step, write the equation for super mesh. Okay, here I3 is in same direction of 4 ampere. So I'm going to write I3 minus of I2 is equals to 4. I call this one as 1, this one as 2. Okay, now applying KVL to super mesh. This is a super mesh. Applying KVL to super mesh. It means we need to apply the KVL in the outer loop like this. Okay, now Tell me. Minus 5.
I2.
Yeah.
I2 minus 15 I3 equals 0.
Yes. KVL for super mesh. I get minus 5 I2 minus 15 I3 equals to 0. I call this equation as. Okay. Now solve equation 1, 3. Tell me the values for I1, 3. Please make it fast. I1 we know from equation 1, I2 and I3. Tell me the values for I2 and I3. Solve equation 2 and 3.
I3 is equal to 1, and I2 is equal to minus 3.
Yes, I2 equal to minus 3 ampere, I1 equals to I3 equal to 1 ampere. Here, tell me the values for IN. IN
I1 minus I2.
IN is nothing but I1 because why I1 minus I2, why not I2 minus I1?
Sir, I1 and IN are in same direction.
Yes, so I1 minus I2 is equals to IN, that equals to I1 is 2, I2 is minus 3, that is 2 plus 3, 5 ampere. You got IN is equals to 5 ampere. Okay, in question find the current through 10 ohm resistor. That current is 5 ampere. Okay, now we need to draw a equivalent circuit for Norton, where what it states, a network with a two terminal will be replaced with a equivalent current source and a resistance in parallel with that. Okay, now see here, I remove this. Okay, for calculating Rn, for drawing the equivalent circuit, we need IN as well as Rn. Okay, here this is the circuit for that. Here same steps we are going to follow. Open circuit the current source, short circuit the voltage source. Okay, here this is the 10 ohm resistor. I am going to replace with open circuit to calculation of Rn. Okay, here I'll mark this one as A and B. For calculating IN, I am going to short circuit. For calculating Rn, I am going to open circuit this one. Okay, here in question only is given as 1 ohm, 5 ohm and 15 ohm. Okay, points A and B. I need to calculate Rn. Yes, here 5 and 15 are in, see, 5 and 15 are in series and parallel with 1 ohm. So I can write 20 ohm, 1 ohm, AB, this is Rn. So my Rn is equals to 1, see R1, R2, R1 plus R2, that is 120 divided by 1 plus 20. 20 divided by 21, how much? 20 by 21.
0.952.
0.952, 9.23 or
9523, sir.
yes, 952. 3 is it is enough. Okay. Rn is 0.952. Now I need to draw a equivalent circuit. This is the equivalent circuit. In in parallel with Rn. Here load resistance RL. Tell me of load resistance. Yes. In question, what they ask, the current through 10 ohm resistance. That is nothing but my load resistance RL. Okay. This is 10 ohm. This is 0.952 ohm. This is 5 ampere. This is my equivalent circuit. Okay. Now find IL. From this find current flowing through RL, that is IL. IL equals to current division. Yeah. Total current into opposite resistance, that is 0.95 divided by total resistance Rn plus RL. IL is equals to how much? Phi u into current division IL. I am finding IL. IL is equal to total current into opposite resistance divided by sum of the circuit resistance, that is Rn plus RL. Total resistance. IL equals to how much?
0.433.
0.433. 0.433.
So 0.4.
Yes. Fine. Next problem. You need to tell me, you have to answer this one, okay? How many sources are there? Two sources are there. 20 volt, 2, 8 ohm, 12 volt, 10 ohm. Okay. Find the current through 10 ohm resistance. Find the current through 10 ohm resistance. Okay. Now, first step. Tell me, what is my first step? Find the current through 10 ohm resistance. First step.
Short circuit 10 ohm.
Yes, short circuit 10 ohm. I'm going to short circuit this one. Otherwise, I'll write another diagram so steps can be remembered. If they ask in question, they ask find the current through 10 ohm. So I'm going to short that 10 ohm. Okay, then I'm going to mark the terminal. This one, if I short 10 ohm, the terminal of that 10 ohm, I'm going to mark as A, B. Then current I. Are there? Next step, loop current I1, I2, two loops, two loop current. Okay, now apply KVL for loop 1. Next step is apply KVL for loop 1. Yes, tell me. This one is current entering point plus minus here also plus minus. Okay, KVL for loop 1, minus 5 I1, then minus to positive potential gain, that is plus 20, then minus 2 I2 minus I1,
I1 minus I2, sir.
I1 minus I2. Why? Because we are writing KVL equation for loop 1. Which one is dominating? I1 is. So I1 minus I2 is equals to 0. Okay, if I simplify this one, I will get 7 I1 minus 2 I2 is equals to 20. I will call this equation as 1. Now same, apply KVL for mesh 2. Okay, apply KVL for loop 2 or mesh 2. Yeah, tell me this one. Minus I2 minus I1 minus 8 I2, then plus 2 minus potential drop minus 12 equals to 0. If I simplify this one, I'll get minus 2 I1 plus 10 I2 equals to minus 12. I call this equation as 2. Now I got equation 1 and 2 from two loops, two loop currents, two equations. So I need to solve equation 1 and 2. Solve equation 1 and 2. Yes, solve this equation. 7I1 minus 2I2 equals to 20 and minus 2I1 plus 10I2 equals to minus 12. Solve equation, then tell me the answer for
I1
I1. I1 is
2.66.
no. Yes.
Yes, sir. 2.6
Yes, 2.6 ampere. I2 is
minus
Minus
0.6.
0.66.
yes minus 0.67 ampere. Okay. Now tell me the values for IN. Here we can see IN is in the same direction of
Minus
I2. So whatever the values of IN will be the values of IN is RN. IN we calculated. Now IN. For that we need to see here. Next step, I am going to mark it here only. Okay. First step, short circuit the resistance, calculate IN. Now for calculating RN, open this 10 ohm. Open this 10 ohm. Okay. Mark these points as A and B. This is RN. Okay. Now for calculating RN, we need to short circuit voltage sources. If internal resistance are there, then replace the internal resistance. Here no internal resistance was given, so I am going to short circuit the voltage sources. Okay, fine. Now tell me the Rn. 5 2 are in parallel, then is
So
A2.
9.4 to Rn.
Rn is
9.4 to
9.4.
yes. Rn equals to 9.42 ohm. Okay. In is 0.67 ampere. Rn is 9.42 ohm. Now, next step. What is the next step? Need to draw a equivalent circuit
Equivalent.
with Rn and In. Here, after calculating In and Rn, we need to draw a equivalent circuit. Okay. With the load resistance, that is 10 ohm. Okay. RL, Rn, In. What is the value for In? Here only, tell me.
minus 0.
Minus
Minus 0.
0.67 ampere. Rn is 9.42. RL is
9.4.
10 ohm. Okay. Now we see here this In I marked like this, in the sense current is flowing like this. I have marked. Now if I mark this one downside, circuit, now I need to find the IL, current flowing through RL. IL is equals to total current 0.67
0.32, sir.
into opposite resistance and plus total resistance. How much?
0.32.
Yeah, 0.32 ohms, right?
Ampere.
0.32 ampere in this direction. Sorry, point.
So down direction.
Yes. See, if I'm going to mark this one, see, this down direction, in the sense I had to take this one as minus 0.32 ampere, because I marked opposite direction, right? So IL to plus 0.32 ampere in upward direction. If I'm going to mark this IL here, then this will be plus 0.32 ampere. This will be minus 32 ampere. Anyone, if you make the direction is like this is plus, because same direction, ion is in same direction of IL. If I'm going to mark in the opposite direction, then minus 0.32 ampere. Okay, understood, right?
Yes, sir.
Yeah. Now next with some dependent source, or 1 minute, dependent source example. Okay, next class we see the dependent sources. Now another simple example on independent sources only. Okay. Now this is a circuit. See, quickly you have to tell. Now we solved two examples. 50 volt or 50 ohm, 20, 10, 10. Okay, these are the values given from. So I'm going to mark this one. Remove all zero. Now you need to tell me. Okay, this is a circuit given. Now find the current through 1 ohm resistance. Find the current through. Find the current through 1 ohm. Okay. First step. What I need to do?
Short 1 ohm.
Yes. Short 1 ohm. Short 1 ohm. Then mark this terminal A and B. Then find the current IN. Correct? Next. How many loops are there? Loops are I3. Okay. Then we need to solve I1, I2, I3. For that, apply KVL for loop 1, loop 2, loop 3. Yes. I1, tell me. For loop 1. Loop 1. Then loop 2. Loop. Yes.
I1 is equal to 1.25.
First tell me if what have
Pi
drawn here
minus
I1,
4i,
I2, I3.
pi minus 4i1 is equal to 0.
No, first tell me if I'm going to short circuit that. Okay. The 50, see, for 50 ohm and 40 ohm connected across the, see this one, this 5 volt is connected across 4 ohm and